Today I want to review the concept of a one-dimensional array. Now, up until this point, we've just been working with regular variables, so we might say something along the lines of int I is equal to 1. What's important is that I is just a single simple variable, and if we take a look at what I might look like in memory, on most systems I is going to take up 4 bytes. So the amount of memory of each one of these blocks is 1 byte of memory. So if we take a look at I and we say 1, 2, 3, 4, I might take up these 1, 2, 3, 4 blocks of memory, and the value that we're going to put into I is going to be 1. And this is just a single simple variable that can just hold an individual value. Well, what if we want to have an array of values? That is, a variable that stores multiple values. So we might say something like int ages sub 5. And now what we're looking at is this actually creates an array. And there are actually 5 different locations that are associated with ages. And each location, since it's an int, corresponds to 1, 2, 3, 4 bytes of memory. 1, 2, 3, 4, so this is ages sub 0, 1, 2, 3, 4, 1, 2, 3, 4, ages sub 1, 1, 2, 3, 4, ages sub 2, and so on. Now the other important thing here is how do we know what the size of an int is? Well, we know that if we said size of an int, what is the size of an int? The size of an int is 4 bytes. Now what can we do with an array? Well, we can say something along the lines of, we can say ages sub 0 is equal to 10. If we said this, then ages sub 0, so sub 0 is this particular position right here, is equal to 10. So the value of 10 is going to go into these 4 locations. And I don't want to talk, right now about the order and where, and that's kind of an architecture issue in terms of how 10 gets stored into memory. The important thing is that ages is an array, and again it has 5 different locations, and which location you decide to use is based on what's called the index or the subscript. So index or subscript of the given array. So when we say a sub 0, the index or subscript is 0, we're placing 10 at that particular location. Now we can use either a single simple integer value here, or we can also say something like ages sub I is equal to 20. Now I has a value of 1, so in essence we're saying ages sub 1 is equal to 20, and the position over here, so we're going to go ahead and place a 20 into this location. And we can also say something like ages sub 2 equals ages sub 1 plus ages sub 0. We can say something that looks like that, and that says take what's in ages sub 1, which is 20, add to it ages sub 0, which is 30, and put that into ages sub 2. So we end up with something over here that looks like 30. So we see where the subscript can be a simple integer value, it can be a variable, we can take different array elements, so each one of these is an array element. So this is an element. Same thing here, this is an element, this is an element. All of these are array elements. So that's kind of a quick review on arrays, how arrays are actually stored into memory, the difference between a single simple variable I, which is able to store only one particular value, but an array ages, which is able to store multiple values. So what I'd like to do now is, with that understanding, let's take that and do something a little bit more complicated here. Let's do a little bit of programming and see where we end up with. So in this particular case, what I've done is, remember that we can take an array ages, and there are up to 5 values here, and we can use an initializer list. So I've stored 18 at ages sub 0, 20 at ages sub 1, 22 at ages sub 2, and you might ask, well, what about ages sub 3 and ages sub 4? Well, they exist, but at this point in time the values are actually undefined, so you don't know what those values happen to be. Now, a lot of times what we want to do is we want to use the concept that we talked about last time, which is function in conjunction with ages. And let's do something that basically what we want to do is let's say we want to find the average of the values that exist in a given array. And we want to do that through a function. So we have integer values here, and so what we want to do is we want to return an int, and let's call the function find average, and what we're going to pass in is an integer array, so that's going to look like an int. This is how we do it in C++, and we want to pass in a size, so it's ultimately going to look like that. Now this is actually called a function prototype. So this is the prototype of the function, and it's going to accept an array, and it's going to accept an integer, and it's going to return the average. Now there's one more cool thing here in the sense that when you're finding an average, you actually don't want to change the array. And arrays by definition in C++ are always passed by reference. So ultimately we want to protect this array, and so what we're going to do is we're going to put a const in front of it. And therefore if find average tries to change anything with the array, the compiler is actually going to flag that as an error. Really nice thing. You want to use that as much as possible, and again, whenever you don't want to change the array. So that's the function prototype. The function definition then is going to look like const int ages, and now down here we're going to actually give it names and the size. So up here we're not going to give it names. Down here we actually will give it names. You could put names up here in the prototype, but the problem there is whatever names you put there must be named exactly that down here. And if you end up changing the names in the function definition, then you have to go back and change them in the prototype, which is kind of a hassle. So what is this going to look like? We'll find average. So we're going to need an integer, and we'll just say we're just going to find the integer average. We're not going to have any decimal value there. Let's set average equal to 0. It's entirely possible that the size of the array might be 0, or it might be some negative number. So we want to go ahead and just assume that the average is going to be 0. And now what we want to do is write the code. So we want to cruise through the array. And so our for loop is going to say I equals 0, I less than size. That says we're going to cruise through all of the values of the array. And what we want to do is we want to find the average of all of those. So we're also going to need some accumulator. So set sum equals 0, because that's going to accumulate all of the values that exist in the array averages. And so once we get into this for loop, we know we have at least one or more values in the array. So we're going to say sum plus equal ages. So ages is our array, ages sub I. We're going to accumulate all of the ages that exist in I as long as that for loop executes. And then when we leave this particular loop, now we're ready to find the average. We know how many we accumulated, that size, we know what the sum is. It's in the variable sum. The only problem now is that, remember, size might be 0, size might be negative. You never want to divide by 0. So we need to put in some test. If size greater than 0, we know we have at least one value, and then we can say average is equal to sum divided by size, and that'll give us our integer average. And then finally return average, and that's the end of our find average. Now the question is does this thing work? So when we come up now, we see we have 18, 20, and 22. We know what the average needs to be. The average is going to be 20, but let's see how things go here. So we want to see out, and we can actually say find average, and we want to pass in ages, and we want to pass in our size, which right now I'm just going to hard code as 3. We want to see out this, and so we might say average equals find average, and then an endl to end this whole thing. Now again, if this works, then we know what our average is going to be. Our average is going to be 20. We're going to come up, we're going to build our solution. Hopefully this thing's going to compile okay. If it doesn't, we'll go back, we'll fix the errors until the thing compiles okay. Don't worry about the one failed. I've got some other stuff going on here. We want to start debugging, and we can see from our results that our average is equal to 20.